Hi, I'm Dave Lane, the director of the Observatory and the software developer of the Robotic telescope. This is the first in a series of video tutorials. This one provides an introduction to the new image processing features. So let's begin. Um, the documentation for the image processing features is on the website under the menu Processing Command Reference. It works quite similar to all the other commands that you would be familiar with if you've already been acquiring images with the telescope. In particular, there's really only one command. It begins with process, and you give it an ID, an image ID to work with, and you give it one or more processing steps and values or parameters associated with some of the steps need additional information. One thing that you can do is not only can you process images that were acquired with the telescope, you can also take the results of those processing operations and process those again. So you can do this in multiple iterations, and it's quite flexible in how it works. So let's start right off with an example. I'm presently using Facebook Messenger to communicate with the telescope, but you could, or I should say in a web browser, but you could just as easily do this on a smartphone or a tablet or in Twitter or email or wherever your account is presently set up. So whatever tool you're used to using, just keep using it. So let's start with an image of M1. So I'm just going to bring up the cues. They are at the top of the menu here. I've added two new queues in the last couple of days. There's a queued processing requests queue, which is empty, which means there's nothing for it to do. And there is also a completed request page. Important thing to remember here is that the processing can happen just about any time except when the observatory is busy. So that means that if it's observing, it does not stop what it's doing to process data. Also, if it's being used manually by our students or during public events, or is down for maintenance or whatever reason, it also will not respond to your requests. But it can always take queued requests. They just may be done later rather than right away. So we can start, just to give us an idea of what's going on, we could do a status and just find out what the observatory is up to. And it's presently waiting for it to get dark and potentially observe tonight, although that's probably not going to happen given the weather we have today. So it looks like it's ready to accept requests. So we'll start off with an image of M1. We'll go back to the queues, find that image of M1 that I want to start with, and I've picked this one called, I guess it's 3162, which is a luminance, 4-minute luminance image that actually looks pretty good. So what I'm going to do to that is I'm going to rotate it, even though that's actually rotated in the right direction anyway, north up. I'm going to rotate it by 45 degrees just for fun, and then I'm going to crop it so that M1 occupies a larger fraction of the frame. So we do that with the process command. So we just do process, we give it the ID number equals 3162, and we give it the steps we want to do. So you can give either 1 or up to 10 steps as one operation. So I'm going to do both here as the one operation. So we'll do the rotate, and then we'll do a crop, and we'll give a parameter for the rotate. We'll rotate clockwise 45 degrees, and we'll crop to within, say, 60% of the frame size. The values are percent of frame size. If you don't give any more than 2 values, it's the size centered. If you give 4 values, it's the upper left corner, left top, and then width and height. But that's in the documentation if you want to use that feature. So we submit that, and it gets accepted, stuck in the queue. So if we went back to the queues and had a look, whoops, that doesn't look like I got there quick enough. So it was done pretty quickly. So there it is. It sends you a notice saying your request was done, a link to the actual request, and it gives you a quick look image of what it looks like. So there we have 60% crop rotated and ready to go. And you'll notice that on the actual image it tells you what was done in that step. So processing is rotate and crop. It also carries through the object name, the filter, and the exposure time. The exposure time is important because it's not only the exposure of that particular frame, but some processing steps allow you to combine multiple images and multiple images into color images and so on. So it attempts to sort of gather together the total exposure time for the entire process. It may not necessarily get that right in all cases, but it should be correct. Okay, so that's the first example. Let's pick another example. This one is going to be M33. So we'll search for that, M33. I've picked this one, 2407, which was taken last November. And what it shows you is that sometimes the images that come back from the telescope can show a gradient across the frame. So for example, the sky background in the bottom left corner is not the same level as the sky in the upper right corner. And that can be caused by a number of reasons. One is we have a lot of light pollution in Halifax, and that means that the sky, it's difficult to get a flat sky. The other reason could be some passing clouds during the exposure that weren't detected by the cloud sensor. There could also be, the moon could be fairly near in the sky, and that actually creates a gradient, natural gradient across the sky. It could also be that the edge of the telescope hits the edge of the dome. It doesn't always perfectly point out the dome slot. Working on that. Anyway, the gradient can fix many of those problems. So let's do that on that image. So that's process ID equals 2407 step equals gradient. And notice I used step. You can use step or steps, either works. And it also doesn't matter the order that you put things on a line. You could put the process command last and the ID after that, and it doesn't really matter the order that you put those items as long as they're all on the line. So that's been requested. We'll wait for it to happen. Essentially what the gradient command does is it looks at the image, tries to calculate where what the background level is in a variety of parts of the image, computes the result, and then flattens the image. So let's look at the result. And you can see it's actually not bad. It's much better than it was across the image. One artifact or limitation of the gradient command is that if your object occupies a large fraction of the image, such as M33 in this case, it can affect the results. So that command may not be useful in all cases. You can just try it and see if it improves the images or not. Generally with most images, the astronomical objects are small, so it works pretty well. Okay, so let's do one more thing, and that's stretching. When I say stretching, I don't mean stretching as in the size of the image. I mean stretching the contrast. And that's very important because in an object like this, M33, the center of the galaxy is actually way brighter than the outer edges. Yet in this image, it's not all that evident. That's because the images that are produced, these JPEGs, are automatically stretched to make the images look pretty good. But if you want to be able to control how they look, particularly in the raw files, the FITS files, then you have to do the stretch manually yourself. And so let's do that. First of all, let's actually look at this image in the raw data and see what it looks like in its raw data. So we'll bring up the FITS file, and we'll bring that up in MaximDL, which is the image processing program that we use at the observatory. You'll notice if I adjust the stretch so that all of the data is actually represented, the galaxy essentially disappears. and all that's left is the brighter stars. If we start to increase the contrast such that we start to see the spiral arms of the galaxy, to see the outer spiral arms, we actually blow away the core of the galaxy, and we don't want to do that. So the way around that is to use what's called a nonlinear stretch, which stretches the fainter parts to a greater extent than the brighter parts, and that gives a more useful image and maintains the level of detail in both brighter areas and fainter areas. So let's actually do that through the social media interface. We'll just turn off Maxim and get back to Messenger, and let's do that again. So we'll work on the flattened image. So that is ID 3303. Process ID equals 3303. And we will do a stretch. Step equals stretch. And we will, there are three kinds of stretches available. S-T-R-E-T-C-H. There's a linear stretch, which you can read about in the online documentation. There's a logarithmic stretch, which doesn't have any parameters. It uses the logarithm function to stretch the data, which works pretty well for a lot of objects, such as comets. And there's also what's called a gamma stretch, which is more flexible. It can be adjusted to stretch both either the fainter areas to a more or less extent, or even accent the brighter areas to a more or less extent. When you enter a value of less than 1, it stretches the fainter areas to a greater extent. And the smallest value you can use is 0.05, so we'll use that just to really show the effect. So we'll run that. By the way, there is error checking on all of these commands, so if you miss a step or enter a value that's out of range or whatever, it will reply and tell you that you've made an error and to try again. So we'll just wait for that to happen. It should happen pretty quickly. And then what we'll do is we'll have a look at the data, that the image that's displayed, which is now no longer stretched using the default auto arcsine H stretch. It maintains the stretch that you asked for in the image that it shows, so it may not look the same as the previous one, but then we'll look at it in Maxim DL and see what it actually does, see what it actually looks like there with the raw data. Okay, so the image will come up in a second. The image comes up as a second message, so it sometimes takes a few more seconds to show up. So you can see it's not as good as the arcsine H stretch. I guess I'll have to add that to the data, but not too bad. If one thing I will mention is you can run the same command twice. So if you ran the stretch again on the stretched image, then the effect would be doubled again. So you could do it multiple times to increase the contrast. So let's look at the raw data. Click on the link, and we'll click on the fits, download the fits, and we'll enable the Maxim so you can see. Okay, hardly anything visible there initially, so if we adjust the contrast, I'm just going to zoom this in so we can see it better. I'm adjusting a histogram adjustment that you can't see, so actually it's not too bad. So that's the gamma stretch image with the flattened image, and it looks pretty nice. So that's the end of the this tutorial. We'll include future tutorials a little later on that include things such as stacking, more examples of stretching, and we'll also work on making color images from images taken through separate filters. Thanks for listening and watching.